Today we're diving into a real cosmic detective story. We're going to crack open a case file, a pretty controversial scientific paper from 2002, and just follow the clues. This is going to be fun. So here's the central mystery we're looking at. It sounds pretty wild, but are some galaxies actually firing quasars out into deep space? Yeah, like cosmic cannonballs. It's a radical idea for sure. So to get to the bottom of it, we need to gather the evidence. But first, let's get a couple key definitions out of the way.
All right, first up, what even is a quasar? Think of it as our main suspect. The official story, the conventional wisdom, is that they're these super bright centers of really distant and young galaxies. I mean, we're talking some of the brightest and farthest things we can possibly see.
Okay, and our main detective tool for this case? It's something called redshift. You've probably experienced this without even realizing it. You know how an ambulance siren sounds higher when it's coming towards you, and then the pitch drops as it drives away? Well, light does the same thing. When something in space is moving away from us, its light gets stretched out, making it look redder. For like 100 years, astronomers have used this as a cosmic measuring stick. The rule is simple. The higher the redshift, the farther away something is. And this is a really important point, so definitely keep that in your back pocket.
Every detective story needs a scene of the crime, right? Well, ours is a galaxy called NGC 3628. It's pretty close by, cosmically speaking, and it's got a bit of a reputation for being, well, a little chaotic. This is where all the action happens.
And here it is. This is our galaxy, NGC 3628. Now, what I want you to pay attention to here are these faint lines, these contours. What you're looking at are just enormous plumes of hydrogen gas getting blasted out from the galaxy's core. This tells us this place is really active, really disturbed. The perfect kind of place to find something weird going on.
Okay, so let's get to our first clue. And this one is a classic, a suspicious crowd. We've got a bunch of quasars showing up in a place they have no business being.
This chart might look simple, but man, it's powerful. Over on the right, that's the normal number of quasars you'd expect to see just kind of scattered around in space. But look what happens on the left as you get closer and closer to our galaxy, NGC 3628. The number just skyrockets. It's totally off the charts. It'd be like walking through a city and finding 10 times more people standing on one random street corner than anywhere else. It doesn't make sense. Statistically, it's a huge red flag.
Just how strange are we talking? Well, the paper did the math. The odds of finding even the closest quasar, right there, just by random chance, 2 in 10,000. Yeah, that's not a coincidence, my friends. That is a clue.
So, okay, we've established that the quasars are all crowded together. But it gets weirder. They're not just in a random clump. There seems to be a pattern to the madness. And that brings us to clue number 2.
Okay, so we're back looking at the galaxy itself. See those circled objects? Those are the quasars. Now remember those gas plumes we talked about? Look at how these quasars line up. They aren't just sprinkled around randomly. They are sitting right on top of the paths that the gas is taking as it gets shot out of the galaxy. I mean, it is a shockingly perfect alignment.
It's almost like the quasars are riding these gas plumes out of the galaxy, like they're surfing a cosmic wave. The paper's argument is that this can't be a coincidence. They must be physically connected, like they were both shot out in the very same event?
All right, let's dig into clue number 3. This is where things start getting really specific, because the astronomers found a pair of quasars that seem to be perfect mirror images of each other. Okay, what you're seeing now is an X-ray view. Right in the middle, that's the core of our galaxy. But check this out. On opposite sides, almost perfectly balanced, you've got 2 quasars. This kind of symmetrical setup has actually been seen around other active galaxies too, and it's a huge hint that maybe, just maybe, they were both created in the same event.
Now here's the real kicker. Remember our redshift rule? Higher redshift means farther away? Well, based on that, these 2 quasars should be at totally different distances from us and have nothing to do with each other. But look at their redshifts. They are almost identical. The paper basically says, what are the odds? The chances of 2 random, unrelated objects just happening to line up so perfectly with almost the same redshift, it's just astronomically unlikely.
So, let's recap. We've got a suspicious crowd of quasars. We've got them lining up in a weirdly perfect way. We've got a symmetrical pair that shouldn't be related but seems to be. The case is definitely building. But now we get to the climax, the smoking gun. This is the piece of evidence that changes everything. Up to this point, you could argue that everything has been, circumstantial evidence, interesting coincidences. But what if there was something more? What if there was a direct physical link, a bridge that you could actually see?
And there it is. Seriously, look closely at this X-ray image. You can actually trace a faint but definite filament, a trail of X-ray light, stretching right out from the galaxy's center. And what's sitting at the very end of that trail? A quasar. And not just any quasar, one with a massive redshift of 2.15. According to the rules, that thing should be billions of light years away, deep in the background of the universe.
The paper itself puts it pretty bluntly. I'll just quote from their abstract. They say the quasar, quote, is at the tip of an X-ray filament emerging along the minor axis HI plume. There's no ambiguity there. They're saying there is a physical bridge connecting a supposedly super distant quasar to a nearby galaxy.
And we're not just talking about some faint X-ray ghost here. When they pointed other telescopes at it, in regular visible light, they found this. A whole chain of little objects, like beads on a string, following the exact same path. The bridge is real. You can see it.
So, after all that, what does it all mean? It's time to lay out all the evidence and see what conclusion the paper's authors came to.
Let's put all the clues on the table. 1. Way too many quasars in one spot. 2. They're all lined up perfectly with gas jets shooting out of the galaxy. 3. We have that symmetrical pair with nearly identical redshifts. And 4. The smoking gun, an actual, visible bridge of material connecting the galaxy to a high redshift quasar. When you put all that together, the authors of the paper came to one pretty radical conclusion. NGC 3628 is literally ejecting these quasars. In their view, these quasars aren't incredibly distant galaxies at all. Instead, they're smaller, younger objects being shot out of a nearby parent galaxy. And if that's true, well, it completely messes with that fundamental rule we talked about, the idea that redshift always equals distance.
And that's where we have to leave this cosmic detective story. The evidence they laid out is, well, it's pretty compelling. And it leaves us with this huge, lingering question. If the conclusion of this paper is right, if some quasars are being shot out of nearby galaxies, and redshift isn't the reliable ruler we thought it was, what else about the universe might we have completely wrong? It kind of makes you wonder, doesn't it?